Hello and good afternoon, CTS266 section 840 students for the spring 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP switch course, and this afternoon's video tutorial is going to be on challenge activity number 12. As you can see, we have the configure HSRP with load balancing title here for challenge 12, and so this is again going to give us an opportunity to take everything that we've learned over the last couple of weeks in terms of first hop redundancy protocols, and specifically with the Cisco proprietary HSRP, and to go ahead and pull it together here in this final challenge activity on the topic. And this is it's a nice little activity here. So we've got a fellow colleague, Gregory, has asked us to do some HSRP work. So the first paragraph here is, again, just background. You can read that at your leisure. Let's jump into what we're going to be asked to do. So router 1 should, whenever possible, be active for VLAN 11 clients and in standby for VLAN 22 clients. And on the same token, router 2, it's just the opposite. So again, we're going to be load balancing. So all traffic for VLAN 11 is going to be going to router 1, and all traffic for VLAN 22 is going to be using router 2 as its default gateway. The group numbers, the HSRP group numbers, should match the VLANs they serve. And this is a very well taken best practice here, that you should, whenever possible, to make it easier for yourself when you have to troubleshoot, or if somebody who follows you needs to troubleshoot, to match the HSRP group numbers to the VLANs that they serve. So the PCs are already done. We're not going to have to touch the PCs. If the uplink fails, make sure the traffic from the PCs does not take a suboptimal path. Now, this is important here, because what they're alluding to here is that if a router fails, we want to make sure that the traffic does not take a suboptimal path. And so we're probably going to be taking a look at some spanning tree setup as well. And then secure the peers, and that just means we're going to be using authentication. We'll use MD5, and you can see here it says make sure that no device can join without the proper key. So we're going to use an MD5 key. So let's go ahead and jump in here on router 1, and let's take a look and see what we've got. So we're on router 1 here. Let's go from user exec. And there we go. Go from user exec into privilege exec, and let's just kind of take a look at where we're at right now. So let's do a quick show run here, and let's take a look at the interfaces we've got configured, because it looks like we've got some sub interfaces we do. So as you can see, we kind of have sort of a router on a stick setup here within the environment, and we are going to be working with Ethernet 01.11 and 01.22. So let's go ahead and knock it out. So the first requirement is that for VLAN 11, router 1 will be the HSRP active router. So let's go into global config, and let's jump into Ethernet interface 01.11, and this is where we're going to go ahead and set up HSRP. So let's choose the standby, and you know what? I did not even look to see. If we come back over here, let's take a look at the job aids here. What are they going to ask us for? I think it's some really nice drawings and diagrams that we can refer to. So the IP address is going to be 10.11.0.2 for router 1, and 22 would be 22.3, but that doesn't give me the virtual IP. I'm assuming the virtual IP we can use .1. Where's it at? Yeah, default gateway. Okay, there it is, right there, .1. All right, so we're going to be using .1. I'm going to leave this up. This is a nice little drawing here. All right, so router 1. So we're going to say standby 11. Remember, we need to make sure that the group number corresponds to the VLAN, and it also will match our sub interface. So standby 11 IP was going to be 10.0.11.1. Now, this is going to be the primary, right? So standby 11, or I shouldn't say primary, the active router. Now, you can, remember, it's going to decrement by 10 by default. I'm going to use the values I use when I set HSRP up. I always like to choose priority of 200. And you'll see what I do on the opposite side when we get into tracking the interfaces. So we're going to say standby 11 priority 200, and then of course we want to make sure standby 11 preempt, because we want to make sure that if this router comes back up after it goes down or loses an interface, that it is going to take back over for VLAN 11. In fact, here's what we're going to do. Let's go ahead and let's put a delay on here as well. Let's do the Cisco best practice. We'll spice this up a little bit. And the minimum delay, remember, how long does it take the router to boot? Let's say it takes 180 seconds, 3 minutes. Well, remember that the equation that you want to use to come up with the time for this value here to allow your routing protocols to converge and to ensure that you don't have interfaces that are going up and down is to say what is 50% of the boot time plus the boot time. So if the boot time is 180 seconds, half of that is 90. So then I simply take 90 and add it to what the boot time would be, and that's 180. So we end up with 270. Because if I do a question mark, you can see number of seconds minimum delay. So I'm going to say 270, and on a reload, we're going to say the same thing. So standby 11, preempt delay minimum 270, and after a reboot, we should also wait for just over 4.5 minutes, or just right around 4.5 minutes before it preempts to take back over again. The idea here is that we're trying to ensure that we give routing protocols and interfaces that may be going up and down an opportunity to converge, to fully converge without interruption. All right, so now let's see what we've got here. So do show run interface Ethernet 01.11. All right, so there is our HSRP config right now. Now, I'm also going to go ahead and we're going to knock out the tracking of the interfaces, because this will be easy enough to do. So standby 11 track. Now remember, with HSRP, I can track objects. However, one of the major advantages of HSRP, or I should say one of the conveniences of HSRP, is that I can actually, there's a native interface tracking here, and that's what I'm going to use right here, is the HSRP native tracking of an interface. So I don't have to create an IPSLA object of any kind. I can just simply say standby 11 track, and we're going to track Ethernet. Which one are we going to track here? Yeah, so I'm going to track that interface right there, because if that interface goes down, Ethernet 00, I have no upstream connectivity here. I've got no way to get out to the internet. So if that interface goes down, I want router 1 to basically decrement the priority value below router 2 so that router 2 would take over, and that assumes that router 2's Ethernet 00 is up and functional as well. So we'll come back over here to router 1, so we'll say standby track Ethernet 00, and then the final value we put in here is if interface Ethernet 00 on router 1 goes down, what am I going to decrement my value by? Now, remember that the value is set to 200. And what I do for the standby router is I'll set the value to 150. So typically what I do is I decrement by 51 to take it to 149. So it'll be 1 under. And again, the reason I do this is because you could certainly leave the default values in here. There's nothing wrong with using the default values. You know, leaving it at 100 or making it 110 and then 100, and then if it defaults by, or if you decrement it more than 10. But I like to put values in so that if someone that maybe wasn't as familiar with HSRP as they were with maybe, you know, another first hop redundancy protocol, or if they weren't familiar with any first hop redundancy protocols, that it would make more sense than them not seeing the value of 100 somewhere. And then not knowing, oh, what is the default? I don't understand what's going on here. So I'm going to go ahead and lock that in at 51. All right, so now if I say do show run, let's take a look at the two interfaces, or actually the one interface right now. So here is Ethernet interface 01.11, right? We've got the standby 11 in there. We've got our track 1 decrement 51. We've got the preempt delay, and the priority is set, so we're good. On router 1 being the primary for VLAN 11. So let's go ahead now, and we're going to do the secondary, right? Remember that it said that for VLAN 22, right, or interface Ethernet 01.22, or I'm sorry, 02. No, this is 01.22. Let me see, what is it? Ethernet? Oh, I'm sorry, it is 02. I was looking backwards there. All right, so interface Ethernet 02.22, and it's going to be this guy right here that we're going to be manipulating. Now, remember, for VLAN 22 on router 1, we are the second, or the standby. So we are not going to set the priority to 200. So let's go ahead and get this set up here. So we're going to say, sorry about that, standby 22, and the IP is going to be 10.0.22.1. And that's going to start this group up. Let's go ahead and say standby 22 priority. Now again, I'm going to set the priority to 150. And we're going to say standby 22 preempt. So I'm going to set the priority to 150 because, again, on the active side, it's going to be set to 200. Now you'll notice that what am I not going to put in here? And actually, let's go ahead and we'll keep with our preempt delay minimum 270. We'll keep this up here, 270. Now you'll notice there were a couple statements that did not make it in here that we had on the other interfaces. So do show run interface Ethernet 01.11, and then let's do 02.22. So you'll notice there is no standby track statement on Ethernet 02.22. So why do you think that is? Why am I not tracking an interface to see if an interface goes down? Exactly, because this is the standby. So, and the reason I make that statement is because we're assuming that if this router does become the active HSRP router for VLAN 22, that something has gone terribly wrong on router 2. So we wouldn't track an interface here as the standby for VLAN 22, because if we're the primary and I'm actively tracking an interface, that tells me I should be the primary. Again, if I'm the secondary and we're active, then there's something wrong. I don't want to have to fall back to router 2 because router 2 is down. That's why I am currently the active HSRP router for this VLAN 22 right here. And so that's why you're not going to see a track and decrement statement, because we are going to be set up as the standby for VLAN 22. Okay. So that takes care of the router 1 side of the equation. Let's go ahead and type in here and let's give it a write mem. All right, so we saved our config. So now let's jump over to router 2. And actually, as we do that, let's go ahead and say debug standby, and we're just going to debug everything for HSRP there so we can see what's going on. So here on router 2, we'll go from user exec to privilege exec into global config. And let's see, from an interface perspective, we should be looking pretty much the same. And we are, right? We just basically have a sub-interface here on Ethernet 01. And we've got a sub-interface on Ethernet 02. So let's do the same thing, but in reverse here. So for interface Ethernet 01.11, we're going to say, whoops, sorry about that, standby 11, IP 10.0.11.1. So that's our default gateway address. We're going to say standby preempt, right? Now remember, we're going to want to preempt. So let's keep our delay the same, 270. And we'll say after a reload, and standby preempt, oh, minimum, sorry, it should have been minimum. Delay minimum 270. And then, what did I say? Reload 270. There we go. All right. So we've got our standby preempt statement in there. So now on router 2, remember, for VLAN 11, standby 11, the priority will be 150. Now again, since this router, do show run interface Ethernet 01.11, since router 2 is the standby, and it looks like we've got a mistake in there. Do you see the mistake on my preempt statement? Exactly. If you forget to put in There it is right there. If you forget to put the group number in, it's going to default to 0, and this can be cause for concern because that statement right there, that standby 0 preempt delay, would have not helped me with group HSRP group 11. So now let's take a look, and now we're going to pull that other statement out of there. We'll say Control A, no. Then we'll take a look. That's right. We've got to get that out of there. So no, standby preempt. And then let's do the command again. Standby 11 preempt 270. Let's see what the interface looks like. All right, there we go. So we're back on track. So I've got my standby IP. I've got the standby, the secondary priority set at 150. Again, it's 50 lower than the primary, which is set at 200. My decrement on the primary is 51, which would drop the primary's priority if that Ethernet 00 interface goes down to 149, which means that router 2 would preempt and take over. And then we've got our delay in there as well as the reload. And so that's it for router 2 with the VLAN 11. Now we've got, we're going to be tracking some stuff here on router 2 for VLAN 22 because we're the primary interface Ethernet 02.22. So we're going to say standby 22 IP 10.0.22.1. Standby 22 priority. We are the primary, so the priority is going to be 200. We're going to say standby 22 preempt, and then let's say the delay minimum is going to be 270, and the reload will be 270 as well. Now, remember, we also need to do our integrated, right, or the built-in interface tracking. So what interface are we going to track? You've got it. We're going to track that Ethernet 00 interface just like we did on router 1. So let's go ahead and say standby 22, standby 22 track Ethernet 00, and I would decrement it by 51. So do show run interface Ethernet 02.22. And that is what we look like, right? And you can see up here, we went from speak to standby. And we are going to go to the active state here. And let's go ahead and check and see. Do show, before we do anything else, let's say do show standby. And so here we are. We are the standby for group 11. And now we're also the standby for group 22. Now we should not be the standby. And I know with IOU, sometimes it takes it a little bit to transition to that active role. Let's see what our hellos are telling us here. Do we have a typo somewhere maybe? So we're seeing that the hellos priority is 150 for group 11. Group 22 is 150. Sorry about that. All right, so let's go ahead and say you all. Let's kill the debugs right now. And let's say show run interface Ethernet 01.11. So for VLAN 11 we're good. What about 02.22? All right, the priority is 150 and we should be good to go there. We've got the preempt in there as well. So what is taking so long? Why do you think it's waiting? So if I were to say do show standby brief, you can see that we are still the standby, even though we should be the primary. Now, if I hustle over here to router 1 and say show standby for 22, you can see we are the active for 22. However, remember, we set the delay to 270 seconds on a preempt. So the preemption delay at a minimum is going to be it's right at about 4.5 minutes before it's going to preempt. And this will show you that that's going to work. And so while we're waiting for that, let's do a quick level set here and make sure. We'll take a look at the scenario one more time. Okay, so we're good with router 1 setup. We're good with router 2. Self-documentation, right. We match the VLANs. We're good there. Default gateways, uplinks should not take a suboptimal path. So we're going to come back to that and we're going to secure the HSRP peer. So let's do the let's do the HSRP peering authentication real quickly here with an MD5 key string. So we are going to do this. Let's start over on router 1, and we will go into global config. There we go. So let's get into global config, and we'll say interface Ethernet 01.11. And all we're going to do is we're going to say standby 11 authentication MD5 key string, and we'll use ABC123. And then let's do the same thing, interface Ethernet 02.22, and there you go. We've got bad authentication now, right? Because we have it set up on one side, but not the other. So Ethernet 0./2.22, we're going to do the same thing. In fact, we're going to run the exact same command, except we're going to say standby 22. All right, so we'll save our config. Let's say show standby brief. Right, so we've got some problems right now because both groups, and it should show unknown now on this side as well, right? So when it says unknown here, you can see it took it a couple seconds between hello packets when we did the authentication with the MD5 hash, but now the standby is unknown because we don't have any HSRP neighbors because we have mismatched authentication. And you can see here, look what happened. We've gone to active for group 22 and group 11, right? So let's fix that. So interface Ethernet 01.11, and we're going to say standby 11 authentication MD5 key string, and we're simply going to say ABC123. Uh-oh. ABC123, there we go. Do show run interface Ethernet 01.11. All right, we've got the good key string in there. Now in the interface Ethernet 02.22. And we're going to use that exact same command, except change the group number to 22. So you see we were still getting bad authentication, but now we should be good. Let's say write mem and save our config. All right, so everything looks good there. All right, let's see what we've got here. Let's say show standby brief. All right, so you can see that who's the standby for VLAN 11 or for group 11? That's us, router 2. Who's active? You can see we've got the IP for router 1 in there. Our state is standby. Right, indicates we're configured to preempt. Our priority is 150, and that's for group 11. For group 22, our priority is 200. We've got standby configured. We're the active. That's why it says under active, it says local. That means router 2. And there is the local IP address. So let's go ahead and say show standby. And you can see that everything looks good. So now there's one outstanding task, and it was talking about suboptimal forwarding. Let me check really quick to see. I believe that link, we've got these redundant links right there. So actually, when we take a look at this, what we would want is we would want, and yeah, that's not going to be a layer 2 link. Let me check something out real quick. Show IP interface, whoops, IP interface brief. So yeah, we don't have a layer 2 looped topology. Yeah, we don't actually have a layer 2 loop topology, so there's really no need to make the spanning tree changes. Because again, each of these switches here, and let me draw on top of this for a second, each of these switches that we've got listed here, access switch 1 simply has 2 connections, one connection here and then over here. This is a layer 3 link. So what we have is a layer 2 non-looped topology, right? If these were multi-layer switches and this was a layer 2 link and not a layer 3 link, then we would have concerns about spanning tree, where what we would want to do is make sure that this would be the spanning tree route for VLAN 11, and that this would be the spanning tree route for VLAN 22, right? But again, since we've got simply the router on the stick connection here on both sides. We basically have just a router on a stick connection, and there's no connection between the switches. One of these links, right, it'll be whichever one here, like if it's router 1 or router 2, whichever router is answering the ARP requests, we have optimal traffic flow from the access layer perspective, regardless of which router is going to be the primary, because we have connections into both routers. This would have been different had we had a loop that we had to take into consideration. And if that was a layer 2 link and these were multi-layer switches, then we would want to come in here and say that's going to be the spanning tree route for 11, and that's a spanning tree route for 22. All right, let's take a look here and see, because I'm sure we've got some validation we're going to want to take a look at. So we already did the show standby. Everything looks good there. I'm assuming from the end hosts, we're going to be doing some trace routing. Yep, so we've got all of the authentication set up. Actually, I don't have us doing anything like that, but let's go ahead and take a look and see what that's going to look like. So if I was to say show standby here, you can see that we've got the authentication MD5 key string, preemptions configured, we've got our delays, everything looks good. So let's take a look at the PCs. From PC1's perspective, if I trace to the internet, what is our internet cloud? Let me see, what is that? What is that cloud going to be? Is there an IP up there that we can get to? Let's see. That would have been in the. Thought it would have been in the job aids. Can I get to this router here? Let's check router 3 here. Let's go into privilege exec and say show IP interface brief. And yeah, let's try to ping 209.165.202, or we'll trace our way to 209.165.200.2. Now, PC1, who I should probably check and see which VLAN it's in, and actually this should tell us. Let's do sort of a blind test here. So based off of the first hop we take, whether it's router 1 or router 2, should tell us what VLAN we're in. So we go to 10.0.11.2, and that is router 1. If we take a look at the job aids, yeah, 10.0.11.2 is router 1. So we should be able to conclusively show that if I come here to ASW1, the access layer switch, and look at Ethernet 01, let's go into privilege exec and say show run. Looking at Ethernet 01, we are in VLAN 11. If I come over to PC2, and we'll do the same trace route, so we'll say trace 209.165.200.2. That's in VLAN 11 as well, and we'll get confirmation here if our first hop is 10.0.11.2. And let's see what we get here. Give the trace route a second. All right, fantastic. Now let's do a check here on PC3. Same thing, we'll say trace to 209.165.200.2, and PC3 should be in VLAN 22, and that's another reason why we don't need to meddle with. It looks like that the VLANs are a local VLAN configuration, meaning that on access layer switch 1, if I were to say show VLAN brief, we do have VLAN 22 defined, right? But we don't have any ports that are active. So it's sort of a local setup here where only VLAN 11 is defined and being used on this switch. So if I come back to PC3, you can see we went to 22.2, which is router 2. And then we'll wrap up here with PC4, and let's make sure that, whoops. We did not want that. And we'll give it a second. There we go. So we'll get into privilege exec, and we'll say trace 209.165.200.2, and we should go to 22.2, and this will prove. And while we're waiting for that, let's jump onto access layer switch 2, go into privilege exec, say show VLAN brief, And again, you can see that we only have ports that are active in VLAN 22. And sure enough, there we go. All right, well, this is going to wrap up challenge activity number 12. Fantastic activity here to allow us to go ahead and configure HSRP in a very real-world setup. All right, thanks for watching, and I will see you guys tomorrow evening.